Hello and welcome to this video for Chemistry 20 in the acid-base section of the solutions unit. We are going to be looking at calculating pOH today. So what exactly is pOH? When we're dealing with a basic compound, a compound that is either an ionic hydroxide or a weak base, but for your Chem 20 level pOH calculations, we're going to be dealing always with strong bases. So essentially, if you have an ionic hydroxide, you have a base. The base, when it's in water, it's not going to produce hydronium ions like acids do. A base, ionic hydroxide like sodium hydroxide, is just going to simply dissociate into its ions, and the key ion that it's dissociating into is the hydroxide ion. Okay, so if we have hydronium ions, which remember are synonymous with the hydrogen ion, that means we have a number on our pH scale. But if instead we have hydroxide ions, we are going to get a value on our pOH scale. Okay, so whatever ions you have lets you know which scale you're going to get a number on when you take the negative log of it. Okay, so if you have an acid which generates hydrogen ions which bond with water to make hydronium, so hydronium is really the more accurate way of saying hydrogen ions coming off of your acid, you get pH. When you have an ionic hydroxide, a base, and you take the negative log, you're going to get pOH. Now, what is the relationship between these two scales? They always add up to 14, which means if I want to find pH and I have pOH first because I have hydroxide ions, I just need to subtract it from 14 and that'll give me a value on the pH scale. So the values are essentially opposite. Okay? We know that everything on the pH scale below 7 is an acid. Well, on the pOH scale, that's everything above 7. That is an acid. Okay? And on the pH scale, everything above 7 is a base, but on the pOH scale, everything below 7 is a base. So the two, again, are opposite of each other, but at any point, you can add them together, and they're going to add up to 14. Okay, so very useful formula to find pH if you have a basic compound and hydroxide ions. Once you take the negative log, you get the pOH. You then subtract it from 14 if the question asks you for the pH. So let's look at this formula and some examples. So our formula for pOH, like I said, exactly like the pH formula we looked at in the last video, but for hydroxide ions. Okay, so my pOH is found by, again, this is a negative, not minus, button on your calculator. You then hit the log button on your calculator and you input the concentration of the hydroxide ions. So either you'll be given questions where you're given the hydroxide ions or you have to find them, and we're going to look at an example of that as well. Now your pOH has the same sig-dig rules as pH. The only thing significant in them are their decimal places. Okay? So when you are doing your calculations and you're dealing with concentrations, significant digits are their total digits. So you're looking at the total digits in the concentration, which when it's in scientific notation is all the number up to the times 10 part. That has to equal only your decimal places in the pOH. Okay, so when I do this calculation, negative log 1.0 times 10 to the negative 11, negative log 1.0 times 10 to the negative 11, we get an answer of 11, but there's no decimal places, and I need 2 decimal places to match the 2 total digits that were in my concentration. So I need to add 2 zeros to get my 2 decimal places to match my 2 total digits that were in the concentration. Okay, so decimal places equal total digits. If we try the next one, negative log 6.22 times 10 to the power of negative 2, we get, an answer. I have 3 total digits, so I want 3 decimal places. If I did this right, I'm just actually going to pull up the answer because I feel like it's not right. The answer, oh yeah, it was right, 1.206. So there is my 3 decimal places to match with my 3 total digits. Okay? So again, what we're putting in our calculator, so for example, the first one, negative button, log button, 1.0 times 10 to the negative 11, and then hit enter. Okay? That's what you're putting exactly in your calculator. Now if we try the next one, I have 4 total digits. So I'm going to need 4 decimal places. 1, 2, 3, 4. 4 digits after the decimal place. The answer is 5.0264. And then the last one has only 1 total digit, so I only need 1 decimal place. Okay, so hopefully you pause this video, you try putting these into your calculator, again, negative log the concentration and hit enter, and then you're going to get, again, a number that you just have to make sure you're rounding to the proper decimal places that match the total digits in concentration. Now, what if you have a question like this, where you are given a compound and you're asked to calculate either pH or pOH? Okay, now even though we're asked to calculate pH doesn't mean we have hydronium ions. You have to look at your compound. If it's an ionic hydroxide, which aluminum hydroxide is, it's actually a base. Bases do not react with water. Acids do to form hydronium, but strong bases, which you'll always have in your pH calculations, do not react with water. All they do in water is dissociate. So I take 1 mole of my aluminum hydroxide compound, and in water, all it does is split apart into 1 aluminum ion and 3 hydroxide ions. Okay? So you do not react it with water and try to force the formation of hydronium ions. The only time you'll have hydronium ions is if you have an acid. An acid, again, is a compound that starts with hydrogen and is bonded to an anion. Then you react it with water to form hydronium. Okay, that's for acids. For bases, you just dissociate them. Just split into their ions. Okay? Now, again, I'm being asked for pH, but I don't have hydronium ions. I have hydroxide ions. I want to find the concentration of my hydroxide, so I can find the pOH first. Because I have a base, again, when I take the negative log of those ions, once I find those ions, that's going to give me a number on the pOH scale. Okay, so even though it's asking for pH, we're going to be getting pOH first. Now, I am given information about my compound. I am given the mass, 6.30 grams. Now, whenever you're given mass, right away, you want to say to yourself, I need to find moles, right? The universal language for the amount of a substance in chemistry is moles. So I'm going to find the molar mass. Aluminum is 26.98. I have 3 hydrogens and 3 oxygens. So the molar mass is 78.01 grams per mole. So our grams cancel and we're going to get left with moles. 6.30 divided by that molar mass was 0.08075. Do not round this answer. If you do not have the ability to store an answer in your calculator or use it from one step into the next, write the entire number down on paper. Okay? I only put a couple digits and then dot, dot, dot on my page, but I'm actually using that entire unrounded number in my calculation. Okay? So now I take those moles and divide by my volume, which was given, but I have to convert it into liters. So I divide by 1,000. 750 divided by 1,000 gives me 0.750. So now I take my moles, divide by my volume, and that's going to give me the concentration of my given, right? I am given this concentration. I had to kind of calculate it, but I was essentially given all the information so that I could find it. 10767, so on, moles per liter. Now this is the concentration of the compound. I need the hydroxide ions because I have a base. If I had an acid, I would be finding hydronium ions. When I have a base, I find hydroxide ions. So the concentration of my wanted equals the concentration of my given times balancing coefficients wanted over given. Okay, my wanted again is the hydroxide ion. So I'm going to replace my wanted with hydroxide ions to remind myself that that's what this is the concentration of. I'm going to multiply by 3 over 1. In front of my wanted, there's a 3. In front of my given, there's a 1. So it's always wanted over given, which is 3 over 1. Okay? So when I multiply by that, the concentration of my hydroxide ion, again, is 0.3230, so on, moles per liter. Again, do not round this answer, okay? So now if I take the negative log of this answer, and this is actually exactly how I'm going to put it in my calculator, okay? I'm going to go negative log second function and hit the negative button, which gives me my answer if you have a graphing calculator. And this is going to give me my pOH, which is 0.4907, so on. But my answer is asking for pH. So like I said, I can convert from one to the other by subtracting by 14. So again, in my calculator, I'm leaving the unrounded answer and going 14 minus that answer. And we're going to get a value of 13.5092, so on. Now remember again, our significant digits, I look back at my mass. What's significant in mass is its total digits. So there's 3 sig digs in the mass. Same with volume, total digits. There's 3 sig digs in the volume, which means I need 3 sig digs in my answer. And again, what is significant in pH are its decimal places. Okay, so I'm cutting it off after the 9. I'm not cutting off a 5 or more, so it doesn't round up. So the answer is just 13.509, and that is our final answer, assuming we did the calculation properly. Let's pull up the notes and make sure that this matches the notes. We get, yep, 13.509 if I erase this and put up what's on the screen. Okay, so a few steps involved in these pH calculation questions of a base, several steps. You have to first write the dissociation equation, then calculate the moles, then calculate the concentration of your given, then find the concentration of your wanted or the concentration of the hydroxide ions. Then take the negative log to get the pOH, then subtract it from 14 to get the pH. So there's 6 steps involved in a question like this, okay? Now I do have a summary of the steps here. So if you are doing, I have this in the way here, we'll move this down. If we are doing a pH or pOH calculation from a compound, okay, so you're not directly given the ions, you are given a compound. First, you need to identify if your compound is an acid or a base. If it's an acid, again, an acid, let's use a different color here so that I can write on here and you can see it. It is an acid if it starts with hydrogen and is bonded to an anion. Okay, so something like HCl or HNO3, those are acids. Those react with water and form the hydronium ion. If you have a base, and it's always going to be a strong base, it's going to be an ionic hydroxide. So what that means is essentially it's a metal bonded to the hydroxide ion. So something like sodium hydroxide or calcium hydroxide, some kind of metal bonded to hydroxide. Okay? You do not react those with water, you just dissociate them to form hydroxide ions. Okay? Once you start by identifying what you have and writing the reaction either with water or just dissociating, you then find the concentration of the compound if it's not already given, with mass over molar mass and C equals N over V. Then you find the concentration of the ions, and again, whichever ions you have depends on what type of compound you started with. If you started with an acid, you have hydronium, but if you started with a base, you have hydroxide. You're going to use the concentration wanted equals concentration given times wanted over given formula for that. Okay? Then you take the negative log of your answer. And if it was hydronium ions, you now have a number on the pH scale. But if it was hydroxide ions, you have a number on the pOH scale. So if the question's asking you for pH and in step 4 you had pOH, you can subtract it from 14. Same thing with if it's asking for pOH and you have pH, you can go 14 minus pH as well. So you can find one from the other by subtracting from 14. Okay? So those are all your formulas and steps required for calculating the pH when you have a compound. So again, an acid example is something like HCl or HNO3. You're always going to be given a strong acid in Chem 20 to do your pH calculations, and you're always going to be given a strong base. Okay? So that is basically it. Hopefully this last slide here helps you again remembering the steps that are required if you're asked to calculate the pH or pOH and you're given a compound, not directly given the ions. Okay, thank you very much for watching this video.